Hello pre-calculus, short one today I hope, the rational root theorem. The first thing before we get into the rational root theorem, what is a rational number? A rational number is any number that can be written as a ratio of integers. So it can be written as a fraction where both a and b are integers and b is not equal to 0. So 1/2 is an integer. 387 over 5,762 is a rational number, not an integer, is a rational number. 0.131817 is a rational number. So long as it ends, you can write it as a fraction. Pi is not, the square root of 2 is not. There are a lot of numbers that are not rational. But if they are rational, then they can be represented as a fraction. Basically, anything that can be written as a fraction, the way you normally think of fractions, is rational. The rational root theorem says if you've got a polynomial, the coefficients are integers, then you can find all the rational roots by finding the factors of your constant term and the factors of your leading coefficient and checking all of the ratios of those numbers. So all rational roots of a polynomial have the form p over q, where p is a factor of your constant, that is the last term, if this is organized in descending order, and q is a factor of your leading coefficient. So you can find all the possible rational roots by using this formula, and then not all possible rational roots are actual rational roots, so you have to check them. So to list the possible rational roots of this function, first you figure out all the possible factors of -3, and those are plus or minus 1 and plus or minus 3. Then you find out all your possible factors of 4, plus or minus 1, plus or minus 2, plus or minus 4, and then set up all the possible ratios. So 1 over 1 is 1, 3 over 1 is 3, 1 over 2 is 1/2, 3 over 2 is 3/2, 1 over 4 is 1/4, 3 over 4 is 3/4. So they didn't do them in the order I would have, but these are all of the possible rational roots. Remember, that's only rational. You can have roots that aren't rational, and those are possible, not actual. You then have to check for the actual ones. So you can use the graphing calculator to narrow down the possibilities. You know that there will be no rational roots less than -3 or greater than +3. But you know that you need to check each 1/4 to find them all. So you set your viewing window, you graph it, you look at this. I actually prefer to look at the table. And then if you find a possible rational root, you can use it to, you can use synthetic division to check it. So the only rational root is 1. I'll show you how to rule out the others. And if you are asked to write it in factored form, not all the way factored, but with rational factors, you'd write it as x minus 1 and then 4x squared plus 2x plus 3. And for the purposes of this section, we're not going to break this down any further. We could, of course, we could break this down using quadratic formula, but we would get irrational values, so it would be messy. First problem on the back. So our possible values of p, that's the factors of your constant, so plus or minus 1 and plus or minus 2. Possible factors of q, q is your leading coefficient. Well, factors of 1 are just plus or minus 1. So your possible rational factors, or rational roots, excuse me, are 1 over 1 and 2 over 1, or just 1 and 2, but you have to check positive or negative for both of them. So -2, -1, +1, or +2. To find the actual ones, go ahead and plug in the function x to the third minus 4x squared plus x plus 2. One thing that can be really useful is to change this. For this one it's not going to matter, but I don't need to look any lower than -2. And I can go every integer. I don't need to look any closer because I've got no non-integer possibilities here. So we're going to look at the table. -2 is not a root because y is not 0. -1 is not a root. +1 is a root. +2 is not. So the only rational root is 1. There are 2 other roots. There have to be, because there need to be 3 complex roots. So you have 1 rational root, which is x equals 1, and 2 irrational roots. And if you're curious, the 2 irrational roots are 3 plus the square root of 17 over 2 and 3 minus the square root of 17 over 2. But you don't need to find those. For today, you just find the actual rational roots. So, possible rational roots of number 2. Our possible p's are plus or minus 1 and plus or minus 3. Our possible q's are plus or minus 1, plus or minus 2. So what are our possibilities? Plus or minus 1, plus or minus 3, plus or minus 1/2, and plus or minus 3/2. So to check this one, 2x to the third plus 3x squared minus 8x plus 3. The smallest value I need to check is -3. I need to make sure I get the half steps. So I'm going to say go up by 1/2 each time. -3, look at that. -3 is a root. -3/2, that's -1.5, is not. -1 is not. -1/2 is not. +1/2 is a root. +1 is also a root. Now, this is a third degree function, so it can only have 3 roots. These are our actual rational roots, and in fact, those are the only roots they have. All 3 of these roots of this function are rational. Number 3, possible p's are plus or minus 1, plus or minus 2. Possible q's are plus or minus 1, 2, 3, and 6, factors of 6. So, my possible rational roots are plus or minus 1 over 1, 2 over 1, 1 over 2, 2 over 2, but that's 1, so I won't list it again, 1 over 3, 2 over 3, 1 over 6, or 2 over 6, but 2 over 6 is the same as 1/3, so I'm not going to list it again. These are my possible roots. So the smallest value I need to look for is -2. So I'm going to set my table start to -2, because I know they're not going to be smaller than that. And I'm going to set my delta table to 1/6, because if I go 1/6, I'll catch each of these. So 6x to the third plus 11x squared minus 3x minus 2. Change my table start to -2, and my delta table to 1/6. It'll round it. That's okay. Don't round it yourself, but let it round it. You can put it in its fraction. Check my table. All right, -2. I found one. Nothing until I get down to here. -0.333. That's -1/3. The calculator will round it because the calculator has to, but you should use fractions because -0.333 isn't actually the answer and -1/3 is. Okay, what's next? Anything? Okay, that's a weird one. So 0.5 is 1/2. 1e -12 means 1 times 10 to the -12, which is a tiny number, and that almost always means it should be 0, but the calculator had a rounding issue. So we're going to check that one ourselves, but that's a possibility. And let's go all the way up until we hit 2, just to catch anything else. Nope, that's it. So to check 1/2, there are a couple of different ways to do it. We could do synthetic division, or we could say, we could plug in 1/2 for x. By the remainder theorem, if this gives us 0, then x minus 1/2 will be a root, or sorry, x minus 1/2 will be a factor, which means 1/2 will be a root. If you plug this all in the calculator, this does come out to be 0, so that means that yes, this is a root. 3 rational roots. There can only be 3 roots total, so we're done. Last one, possible rational roots. Plus or minus 1, plus or minus 5 over plus or minus 1. So my possible rational roots are just plus or minus 1, plus or minus 5. Check that in your calculator. You can do it. The only one that comes out is -5. So the only actual rational root is -5. It's not the only root because there have to be 3 of them, but it's the only rational root. If you're interested, the irrational roots are -3 plus square root 5 over 2 and -3 minus square root 5 over 2. But this is the answer. This is the only rational root. 1 rational root, 2 irrational roots. That's it. Don't forget to do the right homework. Skip number 9 because it's a thing that we no longer do, unless you're interested in it, in which case go read Descartes' Rule of Signs, and it's great. I'll see you soon.